So this is PH tutoring with the with our first works example videos, sequence of videos, and we're going to do question paper 1, foundation to AQA, and it's physics. The specification is 8463, so it's first paper foundation. We're going to make a sequence of short videos on each question. So let's have a look. First question. As the cyclist accelerates, something energy store is in the cyclist body decreases and the something energy of the cyclist increases. So because he's moving, well, what is it that enabled him to move? It was the chemical energy. I think I need a smaller pen. Can I undo? I can. No. Okay, the chemical. It won't let me do dots, annoyingly. So I'll have to do a line like that, which will mean a dot. The cyclist body decreases, in the cyclist body decreases, and the something energy of the cyclist increases. So he's got faster, so it's kinetic energy. Kinetic energy is the energy caused by movement, or the energy. If something is moving, it has kinetic energy by definition. So how to calculate that kinetic energy? Well, it gives you the formula here. So question 2 gives you the mass. It gives you the speed. So kinetic energy is equal to 0.5 times 80 times 12 squared. 12 squared is 12 times 12. Now, you can just type in you can just type this into your calculator and you'll get the answer. But let's just write it down so as we know kind of what's going on. If you want to do it in your head, it would be 0.5 times 80, which is 40. Then times 144, which is 12 squared. Now, I'm not actually going to do that in my head, to be honest with you. I'm going to just put it on the calculator anyway. Let's move this down here. And I move that up there. Okay, so it's 144 times 40. Okay, so 5,760. Joules is giving you if it didn't give the unit, don't forget to use the unit. Okay, you'll lose a mark if you don't include the unit. All right, let's see if we can keep going. We're trying to get all of question 1 within one video. So it's going to be all about energy. The questions will always keep the same theme. When it gets into question 2, you know the theme may change. Okay. So again, it gives you the formula down here, which is nice. Always make sure you read all of the question. So when cyclists use the brakes slow down, it tells you there's a temperature increase of 50 degrees C. They could have given you the starting temperature and the final temperature, and then you would have to work out the increase, but they didn't do that. They gave you the increase, which is nice. It gives you the mass. It gives you the specific heat capacity. So this, let's just make sure. It looks like we're just going to put it into the formula, but let's just make sure of it. We want to calculate the change in thermal energy. Well, that's what this is down there. So that's going to be equal to the mass 0.04. The other thing is that we want it in kilograms, and again, it's already in kilograms, so that's fine. I'm going to times it by the specific capacity, which is 480. And then times that by the temperature change, which is 50. So apologies for the decimal place looking like a comma, but it just will not let me type in a dot for some reason, or make a dot. Okay, so that's 960. So the answer should be 960. Okay. Right, let's keep going. How is the internal energy of the particles in the brake pads affected by the increase in temperature? Well, temperature, if you have an increase in temperature, it means the particles are moving more quickly. So and that's manifested as kinetic energy, so which is part of internal energy. So internal energy of the particles is going to increase. Okay, so increase. All right, so I'll stop the video there and I'll make the next one for question 2.